Ladies and gentlemen, esteemed guests, the hundreds that are in the room.
And elsewhere.
And elsewhere, that's right. So, my name is Mike Cass. I am the executive director and founder of a local nonprofit. And the reason why I say that, because this is kind of where it all began for EyeBot, is 4 years ago I left the private America as a senior voice engineer to help the unemployment epidemic for the blind, visually impaired community, because I was always the token blind guy out there. And I started an organization called BIT, which for my chip heads in the room, which is pretty much the entire audience, I took the binary bit, the 0 and 1, and created the acronym Blind Institute of Technology. So technology for the blind, visually impaired is absolutely imperative for us to overcome the very real visual obstacles. And so throughout the first couple of years of Blind Institute of Technology, we're doing our thing, we're getting blind people placed, employed, came across some amazing board members, and I was filling my board up with technology and executive professionals, because I've always known that technology, where it was today for the blind, visually impaired community, to me is 25 years behind where it needs to be. And so I wanted to surround myself with a lot of tech executives and thought leadership. And we came up with this idea when I was talking to one of our co-founders, Kishore Nayak, the former CIO of Gates Rubber, about this idea of like, how can we, Uber gets me from curb to curb, but what gets me from curb to door safely, or even across the campus. And I started talking to him about this idea, and he said, and I was out, my roadmap for like EyeBot, the concept of EyeBot, was 4 or 5 years after Blind Institute of Technology. And so within 18, 24 months meeting Kishore, he's like, let's do this. And so then we got to meet Sumant, who's a former director of innovation at Cable Labs, a small think tank up in Louisville. And so within just, a year after us getting together, we went past vaporware. We actually have an actual app. So we took 4 square blocks. Let's take a fixed location. So overhead map of, let's say, the 16th Street Mall. You guys can all visualize that, right? Now close your eyes. Attempt to navigate that 16th Street Mall that way. It's kind of intimidating. However, the technology is there to allow a blind person to safely navigate that with more than just my cane. So we memorize information, with audio clues, with spatial recognition. Like, all we need to know is like, oh, there's the extended seating area to Cheesecake Factory. So I don't need to necessarily run into it with my cane or my shin for me to know where that's at. And so with EyeBot, it's really exciting. We were able to take, in a short amount of time, we were able to do this within a few days, completely map out from a micro navigation standpoint 4 square blocks of the 16th Street Mall. So giving blind, visually impaired people that access. And when you start looking at the numbers, like, why wouldn't any location, fixed location on this planet, want to serve a demographic that exceeds 280 million people globally? And so with technology as the mitigator, we can now do that. So Sumant, if you want to come on up and do all the nuts and bolts, that'd be great.
Great, I like this. It paints the picture and just like, how does this work? Sure, so there are a couple of different ways in which we can do this. I think we are going to talk about EyeBot as a whole and what we are trying to do there, which Mike kicked off. And Nathan's going to talk about a collaborative effort we have with DO as well. And so before we get started, so everyone here technical who recognizes themselves as a geek? No. Mike can't see, so if you raise your hand, that's okay.
Hey, not a prop, guys, not a prop.
Although he gives me directions at times. I don't know if that's a reflection on me or you, pal. And we want to make this interactive, so you can stop me at any time. We can get into the tech, or we can give you an overview of some of expanding on what Mike said. Any preferences? I know everyone seems to have coffee. Okay, most everyone.
So maybe just kind of a high level on the tech, and then we can go deeper into Yeah, I think this is great. Just kind of like
Sure.
a little bit more detail
Sure.
from the narrative that Mike started on.
Sure. So this is Mike provided his part that in terms to provide a little bit more about my background, just so that you know, I've been lucky in having been in multiple industries. I've contributed to technology development across probably 6 different arcs. Did mobile in the late 90s. I led performance management for Lucent Worldwide and contributed to GSM stuff, and then that was because I saw the plane mobility. Then I went into the internet. I contributed to the Internet Engineering Task Force. So those of you who read RFCs, I co-wrote the subconfig framework and a few others, and I was a working group chair there. But internet is an even bigger connector. Then I went into broadband because dial-up sucked. So you can kind of see the selfishness there, right? So did a startup in California which survived Y2K, got acquired and all that good stuff. But then went into voice over IP because I didn't want to pay long distance charges. And I was recruited as one of the 6 architects at Cable Labs. And Cable Labs, how many people here are familiar with Cable Labs? Okay, so anyone there who has worked there? Okay, I don't see anyone. But nonprofit R&D. Easiest way to describe it is if you have broadband from since we're being recorded, most disliked cable provider anywhere on the planet. Technology was built by Cable Labs, not necessarily, or Cable Labs did the technology development, which is I think 160 million households, and broadband, and a few other technologies. So I led VoIP broadband there. We kicked off wireless, did Internet of Things. But also did a couple of other startups. I currently contribute to healthcare, smart cities, and solutions for the blind and visually impaired through EyeBot. So the context of this to what Mike said, Mike and Kishore have been talking about stuff. We met in at Kishore's office, the corner office of Gates, and this is where it gets both interesting and weird because I was like, downtown Denver looks so peaceful from here, and things you don't say when you have a blind person in the room, right? And his response was, the whole holy crap moment, but he also said, oh, I've been hit by a car a couple of times. And I was like, what do you mean? I was like, oh yeah, and I think he also added, like, Antonio, my friend, has been hit 4 or 5 times. And since then, he's been hit 4 or 5 times too, right?
I'm up to 4 times now, so.
Okay.
Yeah.
So, and what you don't know is, my dad is visually impaired going blind. And the first thought in my mind was, if you can't survive nice Denver, my dad's not going to survive freaking India, right? And I was like, and why do people keep hitting you? Like that cane, like Black people! What's going on, right? This narrative, I'm not going to go through everything here, but it was, that was the genesis. And the next thing I did, which was embarrassing, was, Mike, use your phone for emails and other stuff. Why don't you just open the Maps app? Right? And of course, he schools me on how deficient it is for the next 10 minutes. And I go, crap, okay, that's, good schooling. And, we could actually make this interactive. So how many people here have turned on accessibility on their phones? Do you even know?
I have just for
this. I know you have.
20 seconds or
You're
so.
exempted
Yeah.
from this. Apple did this well for multiple reasons. One is they were sued at one point, and the other is Steve Jobs wanted things to be accessible. Full disclosure, the guy who hired me went on to become a director at Apple, but it essentially, if you haven't looked at it, it kind of like gives you for people. So it kind of gives you stuff there, right? So we said, why don't you just use that and go into Maps? And it's interesting because you can, so it gives you some information, right? But the thing that happens is, what is inherently apparent to us as north, south, east, west is not always apparent to people who are visually impaired or blind, right? It's like Mike, as he said, remembers a lot of things, right? And he has this mental map. I learned that with my dad. We were in Cancun, and the first day we were right outside the beach. And the first day he held my shoulder, walked with me. The next day he was like, "I'm fine." I mean, what do you mean, Dad? It was like 10 steps, 4 steps, 14 steps. and that's all stairs. I know this, right? It's not just because he didn't want help. He didn't want help, but it was just he remembered the whole thing, right? Mike does this, and literally, like, he has given me directions. There was one point when, we were like off I-25, I take the exit, and he's like, oh yeah, the second, traffic light. I'm like, are you really blind? Like, you do the test, right? And he's like, yeah, you took the exit, I could feel the swerve, and, it's always the second traffic light. So that doesn't change, right? It's one of those. But what happens is, it's like, but the north, south, east, west is not really apparent, right? It's like everything on a map is typically aligned either that way or it's aligned based on your location and the relative positioning. So you either have fixed positioning or relative positioning. The other thing is accuracy. If you look at Apple Maps, it roughly has like 100 feet accuracy. Which is not very useful when you're walking, right? And it's like, it's somewhere here. You don't know how many times it's like Mike calls me up and goes, hey buddy, where are you? And I'm like, if you could see, I'm like roughly 30 feet away in one of these directions, right? It's a running joke. And then if you look at, like Apple Maps is 100 feet, Google Maps is, they claim 20, it's roughly around 30. So that's kind of where things came about. And you can check and play with this. So essentially got schooled, and we said, there are two things that we, then the question was, we started whiteboarding things, and Keisha asked the question, so how many people are blind or visually impaired? And roughly, if you take a look at it, it's 21.7 or 8 million in the US, and Mike indicated there's around 285 million worldwide. And we have an elderly population that's only going to increase, 78 million by 2030. And so we started looking at, okay, so what do we really want and to jump straight ahead? Which was essentially, if you have someone like Mike walking the 16th Street Mall, then you typically want them to be able to like avoid obstacles. So let's unpack obstacles. Getting hit by cars, painful, right? But when you're walking, getting hit by trash cans is also painful. Right, so there's static obstacles. There are, like chairs, there are tables. That's equally, disruptive. And things can be dynamic or static, right? Some obstacles are static, but when it snows in the winter, it's like when I was walking my dad testing EyeBot, it got icy, right? And that didn't exist. So, I went around, mapped the whole area, and then it was icy. And my dad was like, wait, you want me to like open up a phone and, when it's cold and you're putting me on icy roads, and now, I don't have traction, right? And I said, just, stay home. Kick the dog, which he did, by the way, which confused the heck out of our dogs. There's one dog, we have two, one is really cuddly, took to him and would lie on his back in the middle of the hallway. We have a ranch style home, right? And we would wait for him to come pet him. And my dad, he's visually impaired, not totally blind, but once it's like evening, can't see, right, completely. So he would during the day, he could kind of like make out stuff, so he would go pet him. As soon as it became 5 o'clock in the winter, he would just go kick him. And he would just be like, what are you doing? I thought you liked me. It's so cold, You like me, do you, hate me kind of thing. But those are the kind of things we started looking at to say, what kind of data can we capture? The other thing, and this is, EyeBot, unlike VIT, is a startup, a true startup, and it's a for-profit. And the reason for that is we realized that if we do create a solution, non-profit mode, and what Mike is doing with VIT is great, it works for that. They essentially get people who are blind and visually impaired, help them obtain and retain jobs, right? Is that a good way to put it? Yeah. Whereas with EyeBot, we said we need to create solutions that are going to help people, and it needs to be self-sustaining. I'm one of the leads at 10-10-10, and we talk about impact entrepreneurship. I advise companies and mentor them and such. And I always tell people it needs to be sustained in some way, right? If you create a business. So the first thing to do was to say, okay, let's actually talk about the landscape. What solutions exist today, right? We are obviously not the first ones to think about this. We're not to be the last ones. We want impact in the space. And we kind of like created this standard 2x2 that we all get bored of, right? But it was essentially blind-sighted obstacles, no obstacles. And the ones, Apple Maps, Google Maps are, clearly map applications, and they work for us, right? But then we had ways that, we kind of like categorize that in the obstacle space, because now you can figure out where the cops are on I-25 so that you can slow down, right? You can find alternative roads that you don't have. Wait, is this being recorded? Crap. On the other side we have like indoors, if you look at it, indoor.rs or indu.rs. Blind Square and others that do provide map app equivalents, but not necessarily obstacles, like unless you program them and take stuff. And then there are solutions for the blind, such as vSpecular and IRA, which are interesting solutions. One of them uses Google Glass and connects you to a live person, and they can give you directions if you don't, if you can't see. And we did go down that road, right? We were like, hey, Google Glass is cool, but it's also like $1,500, and not everyone can buy them, and you don't always have people. There's one business model where they ask people to volunteer time to help people who are blind and visually impaired too. So you connect remotely and such, which is altruistic and noble, but does not always scale, right? I mean, you're not going to always have connectivity. You're not always going to have enough connectivity, especially even in the US. I mean, coming from broadband, it's easy to say there are millions of households who use broadband. It's also, I think, 92% of US households have broadband access. Access does not necessarily mean they have it, right? Just because there's a pipe going down the street does not mean I have access to it. So we started looking at that. The closest that came was Berkeley School of Business got a grant from Google. It was around $750K, I think, and they are trying to do something similar, and but now let's go to technology. I see you shaking your head there, Mike.
Well, some of the solutions that are out there, again, it's, they're all well intended for blind visually impaired. However, many of these solutions are coming from the site-centric perspective. Like, again, hey, if you're solving for me, don't you want me part of that solution? Don't just bring us in for a chat every now and then. Like, we would want that thought leadership as part of the whole solution lifecycle, which brings us to DU and everything else. Like, there's a way to do this where it's sustainable and yet it's relevant for the blind visually impaired that we could absolutely use. It could be applicable. So.
Yep. So now enough of me talking. So let's go into so that whole thing to kind of summarize. We came up with two things. We said for a blind and visually impaired person, there are two things that we can do. One is, how do you create a map that someone who is blind and visually impaired can read? Right, that was one. The second one was, how do you get a person to go from point A to point B, avoiding obstacles, right? Those were the two things it came down to. We had a developer who built this nice shiny app. I mean, I was impressed, gave it to Mike, he was completely unimpressed. Because again, it was built for sighted people, right? It's, I'm throwing us under the bus, but he pretty much said, sucked. And I was like, I agree.
Well, it's not necessarily that it sucked. Is it usable?
No, it sucked.
Yeah.
If it's not usable, it sucks, dear.
Right.
So let's see. So essentially, we have hardware and software solutions, but I'm going to take you through what we did first to solve that. And it's an unsexy app, but I will showcase it. I can come back to people here. Since everyone's far away. We did shower. I don't know about Mike, but I showered. So, and essentially we had to simplify it, and it has two things: explore, navigate. Okay, and that's all it gives. Explore. And I'll do this instead of Mike. Usually.
All good, buddy.
A blind guy doing it is not. It gives you a list of cities, right? So it's essentially. Right. And actually, I shouldn't be showing this. It's for a blind person. And when you select Denver, this goes back to what Mike was saying about 16th Street Mall and the 4 blocks, right? What you see in a traditional map is different, which is again, it goes to north, south, east, west, or rather location. This one, and I'll just do it.
This block has restaurant and coffee options. 16th Street, between Lawrence and Arapahoe, vertical to home button.
So we set up 16th Street as vertical to home button, so that it's always fixed, right? And each block.
Seafood and steakhouse can be found. If you want high-end accessories, Flowers Markets. This is the bluff.
right? So you start
Zoom
going,
in.
and then you can start zooming in.
16th Street, Arapahoe Street, Community Banks of Colorado, the Daniels and Fishers Tower, Skyline Park Hotel, West in Denver. Zoom in.
So I can still,
Level and cross 16th Street to the next block without hurdles. Flower pot. Flower pot. Flower pot.
all, it like, as,
Mushroom. A long patio with many chairs and tables. A projection
does that make sense?
20 feet high.
Okay, so that was the whole thing. We essentially said
Then double to zoom in. Zoom out.
you can zoom in to get more, or you
Zoom in,
can,
zoom out.
get the macro level,
A few options on 16th Street.
or you go into the street level, or then you go into like every obstacle that's out there. Does that make sense?
Yeah.
And I'm gonna turn this off, which is, okay. So that is where we started. And that makes more sense because it's like now 16th Street, it's like vertical to home bun, which is a local, way of like anchoring it. And then you get the macro level. Where are you trying to go? Right? Are you trying to go to a restaurant? Are you trying to shop? What are you trying to do? And then you can zoom in, it starts giving you businesses and streets. You zoom in further, it gives you flower pots on the ground, and patios, where to sit. Does that make sense? Did that?
So those are almost like layers?
Yep,
right?
they are
Kinda
layers.
like zooming in?
Yep.
Okay.
And
Interesting.
if
From
you-
a, and I'm sorry to zoom out real quick, so
Go
from
ahead.
like a blind person perspective too, like, again, like data is very static, and we blind people are gonna memorize, north, south, east, west, the streets, all that kind of stuff, and I've got just about every street from Broadway west mapped out in my head. However, just from pure logistics, however, again, once I start getting into those locations, let's say like this campus, like the Uber dropped me off at the circle just a little ways away from here, and yet for me to get from that little circle over to here, not that far of a walk for a sighted person, because you're like, oh, you just go around this building and it's right over there. It took me 20 minutes in the rain because, again, there's the micro navigation to get from point A to point B. Like, okay, you got in the sidewalks here. I mean, I bet you they're really decorative and they look really pretty. Man, they're really ineffective for a blind person. So there's no north-south grid, right? So, but landscaping, so just that landscaping helped me get that additional layer of data, like saying, okay, yeah, you have sidewalks that are going here and here because you got decorative flower pots. Help me get that additional picture that so that way, next time I'm like, oh, okay, yeah, so I'm gonna kind of swerve off to my left, but I gotta make sure that I kind of follow the grass to the right because the front door of this building is kind of off of that decorative path. So, and so that's, again, it's not that I need to know that it's a flower pot, but in a way it really helps me get from point A to point B, besides more quickly, just more safely, right? So, so that's why we like that was pieces of data that you visually almost take for granted. Like we almost need that as that next layer of like just safety and quality of life.
Yes, and how many people here, I know DU had the alumni day and I wasn't there. Anybody here help us with data collection?
So
They did.
You did, okay. So essentially, the question becomes, where do you get the data? Right, because we already said the existing map applications don't give us granularity of data. How many people here are familiar with Dr. Cog? The Denver Regional Council of Governments. It's essentially multiple cities who band together and fund projects for the common good. I'm simplifying it, but one of them was actually mapping out all the different areas and such. So the map that you see is Dr. Cog data that they provided. Kishore had contacts and they said, hey, if you want to use it, here we go, right? So it gave us more granular data, so which helped us. The second thing we had to solve was things changed. Like I talked about ice, right? It's like how do if I have to go back and program the app every time I see ice on the road, that's not scalable, right? So essentially what we talked about in terms of the DU alumni thing, which Nathan and Matt and others helped us with, is we created an app that essentially helps anybody crowdsource information. So you can create a table in this room, but you can also create it and say there's here are the pathways and such. And if you want to join in on these are stuff I'll just show rather than tell. Some of the people used it. So feel free to walk, come over or not. Let's see. this is not meant to be for people who are blind necessarily, but it's essentially I can capture a walk or a polygon or anything with this. So I'm gonna walk around here, for instance, and it drops pins. Right? It's essentially like telling me, and you can zoom in because it's overlaid on Apple Maps, but I'll show you the results of what happens once it's done. It just captures like my walk, so I can say this is a safe zone, for instance. Or I can go in and say, I can do like a polygonal capture and say something like from, I can add a GPS point here, walk over here and say, okay, this is where the table ends, blah, blah, blah. Now, this won't make sense till you see the results of that, which is, if I go back to the app, I showed you Explore and Navigate. When I click on Navigate, I can select, let's just pick 16th Street Mall. So essentially what I can do here is, it categorizes elements based on what it is. So let's say a restaurant, we talked about Cheesecake Factory. That's the map between here and Cheesecake Factory, right? So it takes all of the data and then processes it and tells you the way to get there. So I can do things like route, so walking route, and that also includes obstacles. So what you don't see here, let me expand it, and I'll pass the phone around so that you can see. So all the data that we map in 16th Street, all those flower pots on ground and everything else that you heard in the Explore mode, gets overlaid. And I'll just pass it on. And essentially, when someone's walking through there, it keeps a circular radius and lets you know what's around you, if that makes sense. And you can process the data from anywhere, anyone can do it, which is what we did on Due Alumni Day, which is we essentially put the app on test flight and people downloaded it and we got paths around the building, which was rich data. And then we could overlay that on a map. And we only captured walks that day, but technically you can also capture obstacles, temporary or otherwise, and now it overlays it on a map. For that we actually use Apple Maps because we don't really need the granularity once you know where things are. Right. And as someone's walking by, like as Mike indicated, it can tell you that this is on the left, this is on the right. You can also use the app to look at obstacles around him. But that's all the good stuff. So let's talk about what sucks, which is GPS. Right. We've all been there. It's like it's on your left. No, it's not. And I can see. With Mike, it takes a whole different turn. But although my favorite GPS story is in Ireland, where it was like keep going straight, and Sarah, my wife, and I were like, I see there's water there. Where are you taking us, right? We're not that down. But then, lo and behold, it actually took us to a ferry and said board the ferry. I was like, holy crap, this is actually great stuff. Because you hear all these stories about people driving into the lake, and people were in one where it was ferry, and we got on the ferry. The whole thing there is, it's like, so we started, this is a scaffolding, right? How do you get the data? How do you put it in there in a form that matters? Then, it becomes, okay, well, if it's cold, if it's winter, you really don't want to have to get somebody to take the phone out, so we've looked at all the hardware augmentation and other mechanisms to help people rather than this, and we filed some patents and other things on that. So that was part of a part of what we did. So this is outdoors. We can scale this. We need to build a platform. We need to figure out GPS accuracy. We have done a few different things there. People here familiar with AdSense, by any chance? They essentially provide APIs that uses sensor fusion to make GPS more accurate. So they take all of the sensors we have on the phone to figure out which direction you're walking. So the same thing that tracks our walks can also keep track of where we're walking, right? So if you know point A, you can extrapolate and go, you took 10 steps this way, and there's a gyroscope and all this stuff, so I can estimate. So that makes GPS slightly more accurate because in downtown, it sucks even more, given the buildings and such. Then we moved on to indoor mapping to say, how do you map indoors, right? how do you map this room? Because it's like, Mike called me this morning and said, I'm here, there's no school in session, so it's just me and some tables, right? And then of course I come over here and he's not here, and I'm like, where the heck did he go? And Nathan found him and brought him over here, right? But it's indoors, navigation sucks even more. There are companies like Indoors that are trying to come up with solutions, but they're looking at it as a data play, right? This is great for malls and other areas where people are trying to find locations, not necessarily accessible yet. So there are certain things I can't talk about because it's still in development, but we started looking at partnerships, and DU has been great, where we said, instead of just trying one thing, let's actually experiment with multiple different ways to do this and see where things go. Right, it's like PhD startup, and it was one of those where we were like, let's hypothesize. We are not, the only people thinking about this, so let's use the brain power of people working on this elsewhere, or get fresh thinking. And so we, partnered with DU. We also worked with a firm out in Kansas to solve some of these things at bus stops, and they're testing out a different prototype on how to help people who are blind and visually impaired find bus routes and bus stops and other things. And there's a firm out in California that's a sister organization that Mike's actually on the board of, and they're trying to help out with evaluating those solutions and such. But now I'll pause and actually questions, make sense? What did not?
So I have a question. When you're
Please.
a little earlier, when you were going through and you talked about how the home button right was the vertical to 16th Street, which kind of makes sense. But does you then have some indication? Maybe I just missed it later, but indication of kind of what direction it thinks you're facing. To your point about the compass and barometer and all the sensors.
Sure. So when you're this is when you're navigating, absolutely it does.
Okay.
Right. When you're exploring,
Yeah.
the idea there.
Exploring.
Yeah. Explore is, as Mike says, it's like there'll be people out in Paris looking at downtown Denver. I would argue it's the other way around, but we'll take that as may. But it is so explore mode is meant to be whether or not you have access, whether or not you're in that location. The navigate is you're there.
Okay.
So if that makes sense.
Yeah.
We had like options on the screen to like press this button if you want to change the orientation, and it's distracting. It's like
Because I was thinking when it was talking, right? The accessibility feedback was talking. I was thinking that it would say something like, the coffee shop is on your right or on your left or behind you, or some kind of proximity sensation to where you are.
So in the explore mode, we deliberately stayed away from that,
Okay.
simply because you can be home and looking at putting a map in your
Makes
mind.
sense.
The other thing is, GPS sucks, but also the directionality can suck.
Yeah,
I didn't want to put
right.
someone in front of
It's
us.
really sensitive to metal, ultralight, and stuff.
Exactly.
I wasn't clear how what we have now helps with being hit by a car. And I probably don't really understand the scenarios in which people are getting hit by cars.
Well, there's the layers of it, right? So start with static obstacles,
Yeah.
right? And then as we continue to build out, it's actually something to collaborate with, Project Excite here at DU. Like, how do you get the technologies to be, then wearable and start to gather in the dynamic? So it's a lot easier to fix for static, than it is for the dynamic. However, it's part of our roadmap for because it's obviously important to me.
No, I get from what I saw, it seemed like it was more of a static solution, but when then I hear about people being hit by a car, that sounds to me like a sensor problem, almost like
Yep.
Yes.
versus
So let's
LiDAR or something like
Yep.
that.
So let's talk about that. So we did, fellow collaborator, Tom Williams, actually built two different systems, one using LiDAR, one using ultrasonic, that essentially starts looking at dynamic obstacles, right? And then we have the DU effort that Nathan's going to talk about that also uses that. The thing, to Mike's point on being on the roadmap is so actually let me take a step back. We started with computer vision algorithms and said, we can use a camera on the phone and we can figure things out. Whether or not, there were things that we could actually do with that. The problem is it's a battery drain, right? You have everything you need, but not the battery. If someone had wireless power, that would be amazingly cool, right? We don't. If it ran on coffee, it would be great, but it doesn't, right? And my background actually, I started in volume visualization and three-dimensional graphics. So there are all the parameters we were looking at, which is, it's not, the complexity boils down to form factors, ease of use, and, ubiquity of the solution. And that did not meet some of those for obvious reasons. So then we said, can we have external augmentation of things that can do this? And that's where Tom built it was actually an ingenious way to use stereoscopic sensors to figure things out without having a camera. And it's good, but it's also bulky. It's an external device, right? He brought it down to a big, but it just was, it's not
still a battery problem.
the same thing, right?
They're not light.
Yeah, they're not light. It lasts longer than a phone, but not light, right? Because the battery is the bulk of it. The LiDAR solution, it has similar things, right? I mean, and there's also a cost issue with LiDAR. It's not down to where you can get it for $2, right? I mean, it went from $600K to probably $300 for a decent LiDAR that we can use, but it's not bad. We've looked at, I'll let Nathan talk about the DU effort, and then I'll circle back on some of the other things we've done. We are open to feedback, so this is not meant to be a one-way, look, we're doing this cool stuff. For us, what would be useful is feedback on things that we may not have looked at.
Are you partnering with other, maybe not obvious, we call it, I guess, projects? Like, I was trying to jot some down that came to mind as you were talking through things, right?
Sure.
Like Project Tango, which is doing interior building mapping stuff, right? And then, I don't know if they're making their data available though at all. And that's a Google thing, so maybe they are, maybe they aren't. And then
full disclosure, Google tried to talk to us a year or so ago, but we were not. Actually, it was about a year and a half. Whenever the event was initiated, the goals were different in terms of how they're collecting data and how we want to use it, and we would not have had access to the data back then.
Okay.
So we kind of said, not right now.
That's not very Yeah, because there's that, there's Project Car, which is clothing kind of sensory, or you can do more things, and then obviously you've already mentioned some of the sensor stuff that's coming out of self-driving tech, right?
Yep.
As you said, a lot of it's expensive, so it's hard to, they're like 300, 500, a couple $1,000 to them is nothing because of the scale they're working with, but you guys obviously, or in the battery aspect, but there is some interesting things out of that too.
Absolutely, and throw them out because I mean, automotive I am familiar because when I did IoT, it was pretty obvious that IoT is like saying the internet, the values and what you build on top of it. So I started looking at verticals, and that included everything from healthcare, energy to automotive. I got laughed at, and I said, Detroit, things are changing, and people were like, cars, never gonna happen. This was 2010, right? I started doubting myself at one point, but I also wrote simulations for self-driving cars back in the 90s, right, on supercomputers back then, which is a phone today. So it was a matter of time, and they have scale. One of the reasons LiDAR is cheaper now is because of the scale.
Exactly,
right?
I know that one specifically came down.
Yep. And there are solutions with brain machine interfaces where, and there are people trying to change things like using your tongue and the receptors in the tongue to be able to see and things like that. There's a lot of innovative stuff, but again, the axes we are looking at, it doesn't meet the cost axis.
Right, and it doesn't solve the immediate need, right?
It does not. That's the whole thing. And I don't claim that we have a solution that's scalable yet because of GPS and other issues. And we don't want to put it out there as yet because we know that this is going to affect lives, right? I mean, not getting hit by cars is one thing, but pushing someone in front of a bus using an app or anything else is not good either, right? So we are trying to walk that fine line between when do we get it out there and how much do we need, but cost, ease of use, all those things are critical factors. To answer your question more broadly about partnerships, absolutely. We have a couple of other non-orthodox people that we are talking to. We have a couple of investors who are interested, at least one of them seriously, who's like, what can we do to make this happen? But we are waiting on, wait till we have things figured out in a way that we can actually deploy it, rather than not. So that's kind of.
Have you tried to do any kind of inspection of satellite imagery or using drones to capture imagery?
Yep.
Big into drones, right? I can see that being very useful, fly over 16th Street and use all the data.
Oh yeah, we actually.
Not that they let you do that, but.
You can get away with some stuff.
Let you as relative, I guess, yes.
It does. There's actually a film in California. Well, we're being recorded, so I'm not going to disclose stuff. But, was doing some really cool things.
Yeah.
We actually had, what I can talk about is, Cable Labs is an R&D organization, right? So we had a drone that, pretty much controls itself, like what was a few years ago. And we spoke to, and this I can disclose, Compass Data in South Denver, for instance. They do a lot of satellite imagery and there's Digital Globe and others. We did look at that. We looked at, we can get real-time, pseudo real-time data, like on a daily, 24-hour basis through satellites. Then we looked at drones and said, can we actually get data and such? The cost factors don't quite add
Still
up.
wasn't, yeah.
No, not yet. In fact, Compass Data was nice enough to give us their super accurate GPS augmentation, which is brings it down to 5 inches, which is great, right? But it also costs $2,500. And we said, no, thank you. We used it for 2-3 months. It was amazing. You go to 16th Street Mall, you can figure out the trash cans right there.
Yeah.
Right? And the good thing is they actually have APIs that you can use in your app, and it works seamlessly, which was amazingly
It's just
cool.
the cost, yeah.
It's a cost. $2,500 does not work. I was like, if you're going to put that in every car, tell me then the cost is going to come down. Right. We've looked at different solutions. There are some that I can't disclose based on NDAs and other partnerships that we have, since this is an open forum. But you can kind of connect it up. So we've looked at multiple different options.
So, go ahead.
Sorry.
2,500 per user or
Per device.
Per device.
Yes. Right. And yeah, that is expensive. Right. There are ways to potentially bring down that cost by sharing it between users in a way. But still, it's like $800 or $1,000, right? It doesn't really reduce the cost enough. Because what we did talk about is, we're not trying to do this in every city across the globe. This is not a Google Maps problem, right? Our whole goal was, let's actually look at cities or states where you have at least 100,000 people who are blind or visually impaired. And Denver is number 10 in the top 10 cities in the US. Snuck it, right? Because it's a scaling problem. Anything we're not going to go collect data in, South Bend, Indiana, to pick on my friends there. It's, if you don't have enough, you can't do it yet.
College campuses and maybe volunteer to do it.
Exactly.
Yeah, so that was kind of my question, and I was able to participate in the
Yep.
mapping exercise at this campus, but it just seems like you already have so many people
Mm-hmm.
with the mapping potential, right?
Mhm.
Like, have you guys thought about, we all have applications and apps installed on our phones, and some of them ask, hey, are you willing to share your data with
Yep.
a marketing organization or some company that's going to try to sell you more crap? I would think that folks would be more apt to share their data with an app or a business that actually is looking to solve a really big problem like this. And if you had kind of that crowdsourcing piece, everybody's walking around with kind of
Well, yeah,
sensors
you
and
can
maps.
keep that sensors on, and then by
Yeah.
having enough people in the same area.
Like
plus
even in this room,
the
right?
imagery,
Like if
that's a
everyone
lot of-
if everyone had their phones on and was sharing kind of that map
Yeah.
data, you'd be able to tell, okay, these are where people are stopping, sitting, these are where people
Right.
are walking
When
in
they walk,
and out
they
of
always walk
doors.
around this way.
Here's obviously where the elevator is.
Yeah.
So,
That's actually, so part of this thought process is, so let's say there's 21 million blind visually impaired people here in the United States, but how many friends and family do I have?
yeah.
That really care about my well-being because they know how many times I've been hit by a car. So it's an exponential factor at that point in time. And so I totally agree. Like, how do you collaborate to get this rich data to keep us safe, right?
Yeah.
Like, I do believe that there's a cause and a push
Yeah.
and a scalable, solution at that point.
Yeah. Totally.
Yeah, absolutely. I mean, I would turn it on and leave it on everywhere I go all day,
Sure.
just to contribute, right?
Those are, I mean, the whole idea, the reason we did the DU alumni, the reason we have the app is for that. So let's talk about that. And so two reasons why we haven't done it.
Yeah.
The first one is GPS still sucks. And like when we started collecting data from our friends and family,
Sure.
we realized that it wasn't accurate always.
Gotcha.
Because when you know, assume
Right.
that you
And
don't
paths like 2 feet apart
Yeah.
completely throw all your modeling off.
totally,
Yeah.
right? And so we were like,
Interesting, yeah.
especially in areas, even around Mike's house, you know, he probably remembers this. We were like, turned on the crowdsourcing, walked around his house, came back, and then looked at the data and went, wait, why is this off by like 10 feet? Which can be a lot,
Yeah.
right?
Yeah.
It's like, oh crap. So then you take the reading again, and people don't do that, right? I mean, it's like, it works great in high density areas, right? If all of us here were walking around 16th Street Mall, I can algorithmically go and say, this is probably the most accurate.
Especially with the AGPS and the Wi-Fi information and stuff.
Exactly.
It's better, right?
It gets, yeah. Whereas if you're walking in the suburbs, not that useful,
Sure.
right? So we, you know, what we haven't shown is architecture, right? The idea here is we are essentially creating a platform. The app is just the front end,
Okay.
right? So the data goes in, it gets processed and everything else. So we are not there yet where our platform can like understand and throw out the noise and take up the signal. The DU thing was great because we knew where the data was being collected, right? So we can look at it and go, okay, this is reasonable accuracy. But if you open it up to everyone, and I, you know, like Nicole was like, hey, I'm at the 24-hour fitness, I just took all this data, do you see it? Like, yes, but I have no idea if it's accurate.
Right.
Right, again, I don't, you know, what we don't want to do is to put Mike in front of us, right? But having said that, that's where we want to go. So that's why we created multiple apps. The other thing is we're trying to like figure out, it goes back to, that's great for static, again, dynamic obstacles. How do you like actually figure that out too? So there are things I can't disclose because we're in partnership with some people to like figure that out. Which would, I think, make a platform slightly more intelligent to like figure out which data is true or which data is not. So right now, what we didn't want to do is to like give it out. I know there are people who are frustrated because it's like, I would collect data for you, right? And we're like, but it's also battery draining right now.
Sure.
We don't want to do that.
And your sensors on all the time.
Yeah, your sensors are all the time, and you know, to go into the nitty-gritties, it's kind of anyone here, you know, if any of you are iOS developers, I don't know if you are, but if you are, you'll realize that, you know, just the way the APIs are, it's an on-off, like it's always on or it's not. And, you know, so there's that, and when it's always on, it drains the battery. Don't ask me why Apple did that, I might ask them, but it's one of those frustrating things. So we're like, can we actually do optimizations here that, you know, would prevent battery drain? The last thing we want is people to turn things off because we're killing their battery too. And we don't have good input, right? That combination just does not scale. So, does that help? Okay, I've taken up Nathan's time. So Nathan, you want to talk about the DU project?
We were just talking about that,
Yeah.
yes.
Oh, yeah.
Sorry, Sue.
I'll shut up.
No.
It's all right.
And real quick, and I love the ideas of this collaboration to solve for, you know, again, the quality of life, the safety factor that for, you know, my community is impeccable. But there are so many, like, it's not just for blind visually impaired that this would be helpful for, right? Like, and so to me, like right now, what the rich data that we have of the 16th Street Mall is the first time ever that we, like a blind person from explore mode, not navigate mode, from explore mode, anywhere on the globe could go and actually get, you know, a fixed location idea down to the flower pile. First time ever. Like there's not another map out there that gives a blind visually impaired person that data. And this all happened within a few days. And so I took that same concept when we talked about Project Excite, which segues directly into Nathan. So I said, how can we make the University of Denver the first virtually accessible campus on the spinning blue ball, period. And that's what we're aiming to do.
So as Mike has alluded to there, that's kind of where the university and Project X-Ray have come into play in this discussion. And to kind of take a step back and talk about why Project X-Ray is involved and what Project X-Ray is Project X-Ray is the initiative for entrepreneurship on campus. It tries to sit at the intersection of innovation, technology, and entrepreneurship. So that's actually what XITE stands for, is cross-disciplinary engagement at the intersection of ITE, innovation, technology, and entrepreneurship. And so Project XA operates in a few different capacities around campus. The first being kind of engaging faculty, staff, and students with the broader community around entrepreneurial activities, events, and distinguished guests, and building relationships along those lines. So we'll do anything from fireside chats, panels, summits, and bigger activities like the flight to Denver that's kind of out of the scope of this discussion. But then we also try to support student entrepreneurship, so whether that's securing funding through pitch competitions or helping them in a more ad hoc way develop their businesses. And then the third kind of bucket that is where EyeBot comes in is we're trying to expose students to entrepreneurship in the curriculum. And so we have a program called Experiments that's being led by our faculty director, Matt Rutherford. And Experiments is based on the idea of experiential learning and taking students out of the classroom and forming cross-disciplinary teams. Anyone across campus can participate, so whether you're a psychology student, math, computer science, engineering, law, business, what have you, you can come together and work on a project for a local startup. So this past quarter, we brought together 6 Denver-based startups to sponsor cross-disciplinary projects for students to work on over the course of the 10-week quarter for class credit. And one of these projects was EyeBot. And so we had a cross-disciplinary team of students that were more heavily focused on math, engineering, computer science, and the like, just because of the technical nature of the project. And the task kind of at hand was described as such that EyeBot has this mapping technology that gets you from wherever you are in the world to the front door of the building you have a meeting at. And that's fantastic, and it's a great step forward and more than exists now. But what about the problem with the last mile? The problem that, okay, now that they're at the BVI individuals at the building that they have a meeting at, how do they navigate up to this room? And in such a huge building with so many different ways of navigating the hallways and the rooms and tables and all the obstacles, how does someone safely and efficiently navigate to the place that they have a meeting or a presentation or something along those lines? And so the idea behind the 10-week project that these students undertook was to develop an autonomous robot to serve as a guide bot that takes a BVI individual from the front door of the building to the place that they have a meeting at. And so our use case was over the engineering computer science building, take them from the front door to our faculty director's office. And so the robot that was created went through many different iterations at first, because at first it was not saying like it has to be an autonomous robot. We were saying what technology can we build that can accomplish this goal. And so, I mean, we experimented with anything from the idea of a Star Wars-like lightsaber with a little handle and a laser rangefinder on it, or things along those lines. But what we ended at was a guide bot. And so Sumant was talking about some of the technology that they've explored in their mapping apps, and some of the technology that made it onto the guide bot includes kind of the computer visions, the laser rangefinders, the LiDAR, Wi-Fi localization, and other stuff that I'm not going to get into too deep of technical detail on. But the idea was that over the course of this 10-week quarter is that these students are to develop the project as best they can for the goal at hand. And so on the project culminated in a demo, and on Alumni Weekend, we also provided a demo of this autonomous robot doing its thing. And while it's still very kind of clunky at this point, the strides that were made in the technology, building it from the hardware all the way up to it actually navigating autonomously by the end of the quarter was pretty remarkable. And this is a program that's going to be continued in the future in greater scale. So while this was a 10-week program, we're looking into having a year-long project, basically, where these students participate in a capstone of sorts to work on this technology and develop it more fully and have the time to really devote to the project and flesh it out to its full potential. And this is going to be kind of a broader theme for Project Excite and for DU in general. DU is a private university for the public good, and Project Excite wants to exemplify that and is participating more in the social entrepreneurship scene here in Denver. We'll be hosting an annual social entrepreneurship summit, and the activities going on around social entrepreneurship and really embracing the idea of DU being a private university for the public good are what's driving the efforts behind some of these programs. So that's all I have to say on the project, but that's kind of the progress and the scope and arc of the narrative there.
Awesome. Cool. Thanks, Nathan. All right, guys. Well, I think we're at time.